right, guys. So what we're doing today is going over sequences and series. So the assignment for tomorrow, so that y'all can be present, is just really the homework for this here, getting this done. Now, for those of you who haven't finished or need to start the test, I'll have you do it Wednesday. And then we'll finish up the note sheets here Thursday, and then that'll be it. There's not going to be a test over this. Now, sequences and series is what we're looking at today. Now, a sequence is an ordered list of numbers. A finite sequence has a limited number of terms. There's only a certain number to them. So finite, so 1, 2, 3, all the way to n, whatever the nth term is, would be a finite sequence. We call it infinite if it doesn't end. It just continues on forever. So a finite sequence, 2, 4, 6, or infinite 2, 4, 6, 8, and it just continues on forever. Now, both of these are defined by the rule 2n, or f of n is 2n, or a sub n is 2n, where n is the numbered term, so whatever term we have in said sequence. Questions on this here? So the first thing we want to do for these here is to find the first 6 terms of the given sequence. So for our first one, we have a sub n is equal to 2n plus 5. So if we want to find a sub 1, the first term, we're going to plug 1 in for n. So 2 times 1 plus 5. Well, 2 times 1 is 2. And 2 plus 5 is 7. Now, a sub 2 would be 2 times 2 plus 5. Well, 2 times 2 is, and 4 plus 5 is 9. Now, a sub 3 would be 2 times 3 plus 5. So 2 times 3 would be 6, and 6 plus 5 would be 11. And we're going to do the same thing for a sub 4, which would be 2 times 4 plus 5. Well, 2 times 4 would be 8, and 8 plus 5 is 13. Our next one would be a sub 5. So we'd have 2 times 5 plus 5. Well, 2 times 5 is 10. 10 plus 5 is 15. And lastly, a sub 6, since we're trying to find the first 6 terms, would be what? 2 times 6 plus 5. 2 times 6 is 12, and 12 plus 5 is 17. So the first 6 terms of this sequence are 7, 9, 11, 13, 15, and 17. Yeah. So that's first one. Well, A and B. Because it had 2 terms, 2 sequences. So the other one is f of n is equal to negative 3 to the n minus 1. So we're doing the same thing, but this time we'll say f of 1. So we're plugging 1 in for n. So we have negative 3 to the 1 minus 1. Well, 1 minus 1 is 0. And anything to the 0 power is 1. Not 0, 1. Anything to the 0 power is 1. The only exception is 0. 0 to the 0 is not 1. Now we can do the same thing with 2. We'd say negative 3 to the 2 minus 1. Well, 2 minus 1 is 1. And negative 3 to the first would be what? Anything to the first power is just the number itself. So negative 3. Now 3, we'd have 3 to the 3 minus 1. Negative 3 to the 3 minus 1. Well, 3 minus 1 is 2. Bless you. Negative 3 squared is what? Negative 3 squared would be 9. Negative 3 times negative 3? Yeah, so if we type it in as negative 3 squared, it will indeed give us negative 9. Because what the calculator is seeing is negative 3 times 3, not negative 3 times negative 3. Now f of 4 is going to be negative 3 to the 4 minus 1. Well, 4 minus 1 is 3. So we can say negative 3 to the third, which is negative 27. Now, what we could have done is said negative 3 to the 4 minus 1. Gotten the same thing. F of 5 would be negative 3 to the 5 minus 1, which is the same as negative 3 to the fourth, which is because what are we doing from one term to the next? So we went from 1 to negative 3. We're multiplying it by negative 3. To the fifth, which should be negative 243, yes? And that's it. Questions on this here? So again, we're doing the same thing, first 6 terms. So a sub 1 would be 1 plus 4, which is 5. A sub 2 would be 2 plus 4, which is 6. A sub 3 would be 3 plus 4, which is 7. A sub 4 would be 4 plus 4, which is a sub 5 would be 9. And a sub 6 is and that's it there. Questions on any of this here? F of negative 2 to the n minus 1. So we'd plug 1 in first. So we'd have negative 2 to the 1 minus 1, which is negative 2 to the 0. And negative 2 to the 0 power is 1. Anything to the 0 power except for 0 is 1. Then for 2, we'd have negative 2 to the 2 minus 1. Well, 2 minus 1 is 1. And negative 2 to the first power is negative 2. F of 3 would be negative 2 to the 3 minus 1. Negative 2 to the second, and negative 2 squared is positive 4. That takes us to f of 4, which would be negative 2 to the 4 minus 1, which is negative 2 cubed. And negative 2 cubed is negative 8. For f of 5, we'd have negative 2 to the 5 minus 1, which is the same as negative 2 to the 4th, which is positive 16. And 6 would be negative 2 to the 6 minus 1, which is negative 2 to the 5th, which would be negative 32. So we get 1, negative 2, 4, negative 8, 16, negative 32. Questions on any of this here? Let's look at this one here. Write the first 6 terms of this. Well, a sub 1 would be 1 over 1 plus 1, which would be 1/2. A sub 2 would be what? 2 over 2 plus 1, which would be 2 over A sub 3 would be 3 over what would A sub 4 be? So A sub 4 would be 4 over 4 plus 1, which would be 4 over. A sub 5 would be 5 over 5 plus 1, or 5 over 6. And lastly, A sub 6 would be so 1/2, 2/3, 3/4, 4/5, and 5/6, and then 6/7. Any questions on any of these here? Now, we can write a rule for the sequence. So if we look at the pattern, like of these here, we can write a rule for it. Now, normally when we do this, we need to look and try to see how the numbers themselves in the sequence kind of relate to each other and work together, as well as how do they connect with their order in the sequence. So -1 is our first term. -8 is our second. -27 is our third. -64 is our fourth. Now, we can look at the difference first. And what's the difference between each of these here? The difference between -1 and -8 is -7. -8 and -27 is negative. And -27 and -64 is negative. What is that? 7. So that doesn't help us much. Because if the difference of these numbers was the same, it'd be considered arithmetic. There'd be a common difference, something we're adding or subtracting. The difference of these doesn't tell us much, because that's negative 12, and this is negative 18. So differences doesn't help us much. But if we think of multiples, what time, so negative 8, or 8 is what, 2 times, and 4 is, so what do we have, 2 cubed, and really for negative 8, it's negative 2 cubed. Negative 2 times negative 2 is negative, or is 4, and 4 times negative 2 is indeed negative 8. How about 27? 27 is 3 times, so we could say this is negative 3 cubed. What about 64? 8 times 8, which is 2 times 4 and 4 times 2, or we could say this is negative 4 cubed, yes? I mean, we could break it down to 2 to the 6th, but that's the same as 4 to the 3rd. Well, could we say that negative 1 is negative 1 to the 3rd? So what would the pattern be? The base of n is negative n to the 3rd. And sometimes seeing the pattern is not always clear, because sometimes it's easier to see than others. Because for this one here, really be able to see it as one knowing perfect cubes, 1, 8, 27, 64 are all perfect cubes, that is helpful to get there. And seeing the patterns and how they work. Because once we get an idea of what the rule should be, negative n to the 3rd, we can test it by saying a sub 1 would be negative 1 to the 3rd, which is indeed negative 1. Then we say a sub 2, which would be negative 2 to the 3rd, which is negative 8. Then we say a sub 3, which would be negative 3 to the 3rd, which is indeed negative 27. And a to the 4th should be negative 4 to the 3rd, which is indeed negative 64. Because we can test it out and make sure that we do get the terms back. Because if we get our terms back, then it is indeed the correct sequence for this here. Questions on this here? Let's wake up. Thank you. Now, if we looked at this here, so our first term is 0, second term's 2, third term's 6, and fourth term is 12. Now, again, one of the first places I would look at this here is see what the difference is between each of these terms here. Well, the difference between 0 and 2 is 2. 2 and 6 is 6 and 12 is. Are those differences the same? No. So it's not going to be linear. And when I say linear, I mean we say like 2 times a number where we have n or our variables to the first power. It's not going to be linear. Now we can look at its difference. The difference between 2 and 4 is 4 and 6 is. So what that means is that we have some type of quadratic, some type of n squared is most likely going to occur. Now we could have n squared, we could have n, and we could have a number, we could have 3 terms. But the biggest thing is that we're going to have n and n being multiplied together in some way. So we might have to do some manipulating with these numbers here to get there. Because our first number in the sequence is 0. So whenever we take a sub 1, we somehow want this 1 and 1 to work out to be 0. Well, we know just leaving it as n times n is not going to work. Because 1 times 1 is 1, not 0. So how can I manipulate this to get 0? So the only way we can multiply together to get 0 is if one of these two is what? So how could I change something here and get a 0? Subtract what? 1. Because now, well, the first one's going to stay, but 1 minus 0 is, and 1 times 0 is. So it works for the first, yes? Okay, so what we have so far is just n times n minus 1, yes? So we just made something that works for the first term. Now we want to check and see, does it work for the rest? If it does, that's great. If it doesn't, we're going to go back and change it and see if we can get there. So this time we'll have 2 times 2 minus 1. Well, still have the 2. 2 minus 1 is, do we have the correct second term? All right, let's say ace of 3. 3 times 3 minus 1. Well, 3 minus 1 is 2. 3 times 2 is 6. Is that the middle term, next term we wanted? Ace of 4. 4 times 4 minus 1. 4 times 3 is 12. Is that all the terms we wanted? So our rule is that there. So with a lot of these here is I try to make, or you're going to try to make a rule that at least works with the first one or the first two, and then try it out and see if it works. And if it works for all of the numbers in the sequence, then it is the correct rule. If not, we change it and go again. So a lot of this is trial and error. Try it out, see if it works. If it does, awesome. If not, we fix it and go again. Because as we saw at the beginning, just n times n didn't work, especially for the first one. It was just 1 times 1, which gave us 1 instead of 0. Questions on this here? So what about this one here? So we can look at the difference. What's the difference between 1 and 3/2? One half. How about 3/2 and 2? 2 and 5/2. 1/2, yes? Well, because we do have this commonality of a half, yes? What's 1 written in halves? Because 2 over 2 is the same as 1, yes? How about 2? Would be what? Because 2 over 2 is 1, so 2 is going to be 4 over 2, yes? Is there a pattern with our 2 over 2, 3/2, 4 over 2, and 5/2? Yeah, there's a 2 on the bottom of all of them, yes? Now we just need to figure out what we need to do with the numerator, top of this fraction. Okay. And again, with any of these here, create something. So we have something, yes? Then we can test it. If it works, then we have the correct thing. If it doesn't, then we can manipulate. We have somewhere to go. So with ace of 1 would be 1 plus 1 over 2. Well, 1 plus 1 is 2, and 2 over 2 is indeed 1. That is our first term. Ace of 2 would be 2 plus 1 over 2. Well, 2 plus 1 is 3 over 2. Is that our second term? Yep. Ace of 3 would be 3 plus 1 over 2, which would be 4 over 2, which is 2, which is the correct middle term that we wanted. And lastly, 4 plus 1 over 2 would be, those are all the ones we wanted, so our rule for this here is n plus 1 over 2. Any questions on these here? And we we can keep going through these, and again, working with these here is really figuring out a starting place or figuring out how the numbers work and going from there. Now, I'll kind of walk us through this one here, and then we'll move on. But 0, 3, 8, 15. This is not always completely kind of easy to see. And if we list out our perfect squares, what is 1 squared? What's 2 squared? 3 squared? 4 squared? So this here would be a sub n equals n squared. Those are all of our perfect squares, yes? Is there a is actually the rule for this here. Because if we take each square and subtract 1, we actually get to these here. That kind of makes sense. And I mean, there's more ways we could have gone about it. Because I could have said, well, we're looking for, again, 2 things multiplied together that would give us 0, yes? Well, we already saw this once. Because n minus 1 did help us get 0, yes? But we know it's most likely not going to be n. Because for our first one, we need, so a sub 1 would be something times 1 minus 1, something times 0 to give us 0. Well, that doesn't help us too much because, well, anything times 0 is indeed 0. It doesn't really tell us anything. But a sub 2, we should have 2 minus 1. We don't want to know the first one, but 2 minus 1 is 1. But what should this give us? 3, yes? Well, what's the only way we can multiply something by 1 and get 3? It's only if this number is 3, yes? Okay. So we have something to go off. A sub 3, we should have 3 something, 3 minus 1. Some number times 2, and we should get 8. What times 2 is 8? 4. We need this other number to be 4. And the last one we have something with 4 times 4 minus 1 is equal to something times 3, and we should get 15, yes? Well, what times 3 is 15? Okay. So we kind of have this set up and kind of working it through. Well, this 3 is going to come from this set of parentheses here, 4 and 5, yes? Well, what can I do to 2 to get to 3? Would that work with the 3 and 4? So we need the first one to be plus 1, yes? So over here we would have n plus 1 times n minus 1, yes? Well, that's a little different than what we had, is it? N squared minus 1? How would we factor n squared minus 1? N plus 1 and n minus 1, because if we did distribute this, n times n is n squared. N times negative 1 would be negative n. 1 times n is plus n, 1 times negative 1 is negative 1. We don't need that. So they actually are the same thing, it's just a different way to go at it. And that's what's with some of these here, it's defining the sequence. There's not a set way to get at it. There's more than one way to get to it. It's just, how do you see it? How do you see the pattern? And how do we manipulate to get there? Questions on any of this here? That's all we're going to be doing today. So your assignment, what you're doing tomorrow, 5 through 11 all. 5 through 11 all.